All right, so we're going to talk about pulmonary ventilation, and we're going to talk about how we get out of homeostasis during exercise, and then we're going to talk about how we try and get back into homeostasis. Okay, so the goal of life is to maintain homeostasis. Exercise, on the other hand, gets us out of homeostasis. We change the partial pressure of oxygen, the partial pressure of CO2, the pH, temperature, fluid balance, salt balance, among other things. But we're going to focus on these three things: oxygen, CO2, and pH, or hydrogen ion concentration. And so, in order for us to keep functioning, we need to get these variables back into that range. Remember, homeostasis is a range. It's not a set point, but it's a range. And so with these three specific variables, we can get back to normal with the help of cardiovascular, muscular, and respiratory systems. So with the respiratory systems, you have to remember or realize that the diaphragm is controlled by motor neurons. Okay, it's a skeletal muscle. So these motor neurons are controlled in the brain by the respiratory centers. Now, there's actually multiple respiratory centers in the brain. You have part of the brain that controls the inspiration and part of the brain that controls expiration. Ultimately, these respiratory centers determine two things: how often are you breathing, and how big are the breaths that you are taking. It's really kind of similar to the heart. The heart can either speed up or slow down, so heart rate, or it can contract harder or softer, which is stroke volume. Now at rest, we've got these inspiratory and these expiratory centers. Well, the inspiratory center is the one that's primarily dominant. Okay, remember, inspiration is active, expiration is passive. And so we don't really need to activate anything during expiration when we're at rest. Okay? This is passive. All you have to do is let your diaphragm contract, and then you breathe out. Okay, we're doing stuff with pressure gradients, and air is able to leave the lungs. But things change when we exercise. Inspiratory areas fire for a longer duration, so this allows us to take bigger breaths. But the expiratory activities also increase their activity so we can get air out of our lungs. Okay, and so that's important as well. Now, not only does just the act of exercise change this, but so does the chemical composition of what's going on. Okay, central chemoreceptors, as I hope you remember, respond to changes in hydrogen ion and carbon dioxide levels. Peripheral chemoreceptors also respond to these, but peripheral chemoreceptors really are looking for oxygen. So when we exercise, what happens to pH? What happens to CO2? Okay, exercise decreases pH, right? We're producing hydrogen ion. That's a byproduct of cellular respiration that occurs in the cell. We get that out of the cell, but then we have to do something with it. It's in the bloodstream. Okay, it also creates more CO2. That's also a byproduct. And so what happens is the inspiratory centers are activated even more. They're stimulated even more, so we take more breaths and we take bigger breaths. Okay, ultimately what this does is this helps us get rid of CO2 and helps us balance out our pH. Okay, remember, CO2 is an acid, so if I'm already acidic but I get rid of a lot of CO2, that will help me become less acidic. All right. Generally speaking, when we exercise, we are not breathing more because we need more oxygen. The stimulus is CO2. Now, that's not to say we don't need more oxygen. We absolutely do. But the response is coming from the high CO2. And by breathing more to try and get rid of the CO2, we're also bringing in more oxygen. And so things are kind of at normal. Okay. And so what this also does is when we breathe more, our bronchioles or alveoli get stretched. Okay. We take big breaths in, right? Now, just imagine when you hold your breath. Okay, what do most people do when they hold their breath? Like I say, hey, I want you to see how long you can hold your breath. Oftentimes, what people do is they take a big breath of air in. Okay, that might be a silly thing to do. It might actually cause you to hold your breath for a shorter period of time than what you're able to do. And the reason is there are signals that are being sent to the expiratory centers saying, hey, we're really stretched out. This is uncomfortable. There's mechanoreceptors. We don't want to damage our lungs, that sort of thing. Okay. This causes or reduces inspiratory time so we don't overinflate our lungs. Okay, and as a result, we don't inflate as much and we breathe out. Okay, the same is true when you hold your breath. If you fill your lungs all the way up with air, there's quite a bit of evidence to suggest that when you start breathing again, it's not even because of oxygen or CO2, but it's because that these mechanoreceptors that you're stimulating because you filled up your lungs, your chest wall, are saying, hey, we're really full. We need to get rid of this air. So in summary, you got to remember the goal is to maintain homeostasis. One of the things that can get us out of homeostasis is exercise. And the ways that we're out of homeostasis can be CO2, oxygen, pH, among other things. And so with the help of these three systems, among others, this can help us get back into homeostasis. So with the cardiovascular, muscular, and respiratory systems.